Okay, in this discussion, we are going to discuss the integration for logarithmic function. Now, in the previous discussion, we know that when we differentiate ln x, we will have 1 over x. And when we differentiate ln function u, now this u is actually a function of x. For example, if we differentiate du dx, right, differentiate ln x squared plus 3. Alright, so this is actually the u. So what we have is actually, alright, we write the equation here, right, x squared plus 3. And we differentiate this one, we get 2x right on top. Okay, so we differentiate this one, right on top. So we will have something like this, right? We differentiate the u, where the u is a function of x. So we actually have u and the differentiation of u. Now, so this actually gives us a clue on the integration of function related to logarithmic function. Okay, so when we integrate this 1 over x, we will have ln x plus c. And when we integrate this, okay, so integrate the u prime u du, we will have actually ln u plus c. Okay, so right, when we have something like this, right, this is the differentiation of the denominator, and we can actually write in this way, and the answer we get is ln u. Okay, so let's take a look on this example. So when we integrate 2 over x dx, so we can actually bring the 2 out, and the function itself is 1 over x. So when we integrate 1 over x, we get ln absolute of x plus c. Right, now we put the absolute here, it is because the value, right, it must be a positive, right? For the logarithmic function, the value here can't be a negative value. Okay, but however, for this x, it can be positive, it can be negative. Now, so in order for this integration to be valid, we have to limit the x here to be a positive value. So we put it the absolute of x, so that in case we have a negative value of x, all right, we will actually change this one to positive value, and then log or ln to this value is valid. Okay, now after that, this 2 we can actually bring up to be the power. So when we bring up to be the power, so we know that this is always positive, and we can remove the absolute function. Okay, so let's take a look on another example here. So when we integrate this, all right, now first we actually know that we can simplify this to 1 plus x over x squared plus 1. Now, how to do this? Now, actually, we can just rearrange the function. All right, this is x squared plus 1 over x squared plus 1 plus, all right, repeat the denominator, x squared plus 1, and this is x. So it means that we actually split the x squared plus 1 into one group and the x itself into another group. And for denominator, of course, we can actually rewrite it. So in this case, this is actually 1. So we have 1 plus x over x squared plus 1. Now, after we simplify this, then we are going to integrate here. Integrate 1 plus x over x squared plus 1. So integrate 1 will give us x. Okay. So, and for this part, now, because we want to have this, right, to be the integration of the denominator, so differentiate, okay, this is the differentiation of x squared. So we add we add 2 to the function. So when we add 2 to the function, all right, we add the 2 to the function here. Now we have to balance it, so we have to divide it by 2. Okay, so we add the 2 because we want to make this the differentiation of this. And when we add 2, we need to divide 2 to balance out. So we have 1 over 2, right, 2x over x squared plus 1. And now integrate this one, all right, will give us ln x squared plus 1 plus c. Okay, so now actually for this part, you can actually let the u be x squared plus 1. And the u prime, differentiate u, will give us 2x. Okay, so the du dx is actually 2x. So du will be 2x dx. So you can see here this 2x combined with dx gives us the du. Okay, and the whole integration now become, all right, integrate of, okay, 2x dx is du. And now we have 1 over, this is u, okay, this one is actually u. So we're going to write the u here. Okay, and this one now becomes du. So when we integrate like this, we will get the ln u directly. Okay, get the ln u. Okay, see. And now we change the u back to x squared plus 1 here. Okay. So another example. Okay, solve the differential equation. The dy dx is 1 over x ln x. Okay, now if this is dy dx, so when to find the y, we need to integrate this. Okay, dy dx is this, so we integrate this one is the y, so we integrate 1 over x ln x dx. So to find the y, we integrate this one. And now as we can see here, actually this one, okay, we can bring the x up here and make it 1 over x. Now by doing this, we can see that actually we differentiate the ln x, we get this. Right, we differentiate ln x, we get 1 over x. So this is the differentiation of this. So we will have the form of u prime. This is the differentiation of this. Okay, the ln x is the u, and differentiate ln x, we get 1 over x. So in this case, right, we are going to integrate this. So we will have, okay, right, 1, we will have ln u plus c, all right, and we apply the log rule, right, the integration of the log rule. So we will have this one. Okay, now finally change the u back to ln x. Okay, so change the u back to ln x. We have ln, the epsilon of ln x plus c. Okay, so this is the equation of y. The integral of exponential functions. So we are going to discuss next the integrations of exponential function. Okay, so from the previous discussion, we know that when we differentiate e to the power of x, so when we differentiate the exponential function e to the power of x, we will get back x. And when we differentiate e to the power of function x, for example, all right, x squared plus 1. So when we differentiate e to the power of a function of x, what we do is we actually differentiate this one, right? We have 2x, right? Differentiate x squared plus 1, we have 2x, and right, we copy the function again. Okay, so in this case, we know that when we differentiate e to the power of u, where u is actually a function of x, we will have u prime then we copy the u. We copy the function e to the power of u. All right, now this actually leads us back to the integration rule for exponential functions. So if we integrate ex, we will get back e to the power of x, right? E to the power of x itself. And when we integrate, right, u prime, all right, a differentiation of u, e to the power of u, we will get back eu plus c. Okay, so let's take a look on the example. So find the indefinite integral, integrate e to the power of 3x plus 1. Okay, so first we are going to let 3x plus 1 equals to u. Alright, so and immediately we are going to find the du dx. So the du dx here is 3. So then, since the du dx is 3, and of course the 3 dx is the du. Okay. So now, in order to get the 3 dx, in order to get a 3 dx here, all right, so that we have du, we can replace the du here. Now we need to add the 3, add on the 3 here, and we have to divide the 3 to balance out. So after that, right, we can actually let this be 3x plus 1 be u, right? So replace this with u, and the 3 dx here replace with du. Okay, so replace this one with du. Now then we have something like this, integrate of e u, right, du. So right, and right, with this, right, integrate this, we will have e of u plus c and a 1 over 3 in front. So finally change the u back to 3x plus 1. Okay, so in this case, all right, so we can actually know that this is actually the u prime. So when this is the u prime, the 3 is the u prime. Okay, this is the u prime, which is the 3. So when we have integration 3e 3x plus 1, this is the u prime, and this is e to the power of u. So when we can actually use the integration of exponential function rule to solve this. Now, what if we have the integration of exponential functions that have bases other than e? Now, this is the formula we can use, right? We integrate a to the power of x. Right, so we get 1 over ln a. The ln a is actually the base, ln the base. Right, then the ax we just copy, right, plus c. Now, for example, if we want to find integrate of 2 to the power of x dx. So what is the base? The base is actually 2. So apply the formula. We have 1 over ln base, ln 2. Then we copy this function 2 to the power of x plus c.